Exercise 328 says amphotericin B is a powerful antifungal agent used for intravenous treatment of severe fungal infections. It's very hard to treat fungal infections. Fungi have very similar chemistry as animal cells do. And so things that kill fungi tend to also kill animals, so it's very hard to treat these infections. But you can do it with something like amphotericin B. And so this question is saying, some of the hydrogens in this molecule are acidic. Identify the most acidic hydrogen. Now, there are a lot of hydrogens in this gigantic monster molecule. But we don't have to go through them all one at a time. We can use these 4 principles we learned to very quickly find the most acidic hydrogen. All of the hydrogens in this molecule are either on a carbon, a nitrogen, or an oxygen. Those 3 elements are in the same row, and as we saw, in a row, the hydrogen on an atom that's further to the right is more acidic. So already we can ignore dozens of the hydrogens. We just want to pay attention to the hydrogens on oxygens. So it's going to be one of those hydrogens that are the most acidic. Well, that narrows it down a lot, but there are a lot of orange dots there, so it doesn't narrow it down too much. And so the next thing we want to look at is resonance. Well, you have resonance when a hydrogen leaves behind an allylic lone pair, or a lone pair next to a positive charge. There's no positive charge in this molecule, so we're going to look for an allylic lone pair. In other words, we want to look for a double bond close to one of these hydrogens. And we have that right here. Let me do that in a different color. We have it right there. This hydrogen that I just highlighted in blue, that hydrogen is the only one that will leave behind an allylic lone pair. It leaves behind the most resonance, and so we know that that is the most acidic hydrogen. All of the other hydrogens are not allylic to a pi bond, and that blue one is. So that hydrogen is the most acidic hydrogen in this big gigantic molecule. So you can see the power of these principles. You can very quickly, if you understand them, you can very quickly apply them even to very large molecules. So for example, if you had a patient who needed to be treated, but if they took amphotericin B and they were getting like stomach irritation because it was causing too much acidity in their stomach, something you can do is you can do a chemical reaction to bond something to this position. Maybe you can get rid of this double bond here, make it a single bond. And if you did that, then this would no longer be allylic, and so the molecule wouldn't be as acidic, and so it wouldn't disrupt your patient as much. So it's the kind of thinking, the kind of effect you can have, even just by knowing these 4 principles, these qualitative principles for assessing relative acidity.